好，现在呢回到了3D 列印的国际研讨会的现场呢，接着是第2位的专题演讲贵宾，那么他是Chaw Sing， 也就是来自于新加坡的一位3D 列印专家。那么呢，他是新加坡国立3D 列印创新聚落的董事总经理，所以呢，在3D 列印的产业当中也具备了相当丰富的经验。更重要的是呢，在 NAMEC， 也就是刚刚提到的国立3D 列印创新聚落呢，他们主要的宗旨是希望能够把新加坡的3D 列印技术扮演国际领头羊的角色，所以呢，他们希望能够在成为国际上3D 列印的翘楚的同时，马上要来听一下就是 Dr. Chaw Sing 他带来的演讲，让他来谈谈关于新加坡现在发展3D 列印产业的最新情况。
And I must say, I'm very impressed with the technology progress that's been made in this additive manufacturing space. For today, what I'll cover basically is 4 topics. When I was preparing this, I was thinking that perhaps there will be students and perhaps there'll be academia and as well as industry members. So I thought it's good to sort of paint a picture of what's the current outlook in the 3D printing market. There's also some vertical sector analysis, which I leveraged from the analysis by Frost & Sullivan, just to share with the audience. And then at the same time, from there, I share with you what Singapore is doing in this space. So I guess for all of you here, you're all additive manufacturing experts, enthusiasts. You would know this story. This journey has been, I would say, has been around for at least 3 decades. Started from rapid prototyping. In recent years, we have seen a lot of good examples coming from the industry announcement, especially from GE Additive, as well as the entry of Hewlett-Packard into this space. So this spells a great promise, and I guess when giant companies, big companies like this, enter the market, you know that the market is pretty much ready, right? So this is a hype curve that I guess again most of you may have seen, and I've been looking at this chart since 2 years ago when I first was recruited by the government of Singapore to join this outfit. And you can see that in different applications, whether you're talking about printing bio products or more conventional tools and molds, everything is basically advancing, right, in this space. So through the, if you talk about organ printing and tissue, obviously these are still pretty much hyped up at this juncture, although there has been a lot of science research outputs in the recent years that suggest that this is no longer science fiction. I think in the current state of affairs, you can see that the 3D printing service bureaus, whether it's in the United States or Singapore, we're starting to see companies springing up, offering very specialized services for either prototyping or manufacturing. And of course, if you talk to people around us, you can see these are typically some of the concerns. A lot of companies that I talk to in Singapore basically say that there's potential, but they're not really sure what sort of business value add is going to bring to them. There's generally a lack of infrastructure in the private sector. Okay, I won't comment too much on public sector. Obviously, there's a lot of government funding, but private sector still needs a lot of space, a lot of investment in the next several years in order to make this technology truly impactful and transformational. And of course, there's still very much, as much as technology has been in research for so many years, there's still very much lack of standards in several application space, particularly in the making of highly complex parts, whether it's for aviation or the biomedical products. Economics of 3D printing, you can see that the excitement around 3D printing, of course, offers mass customization at a cost that is not possible with traditional manufacturing technologies at a scale level. If you talk to different power users, you will notice that I think in the space of product development, this is a fantastic tool and technology for most of the product developers. Whether you're a consumer hobbyist or you're building products for the enterprise space. This is truly transformational technology. And I think all of you would agree that 3D printing costs in the future will definitely decrease with the amount of effort and focus and resources poured in. Now a little bit on the market outlook. So this is taken from a few of the published research reports that I managed to take leverage. So since we are in Taiwan and we are part of Asia Pacific, I thought it's good to give a view of Asia Pacific. So actually Asia Pacific has the most amount of manufacturing activity in the world. It's about half of the $12 trillion in manufacturing revenue actually exists in Asia Pacific today. And according to the report, we believe that this is going to take the lead in 3D printing growth, especially in Asia Pac. At the current moment, North America and Europe actually still account for 2/3 of the 3D printing market revenue. But most reports believe that Asia Pac will catch up. Okay, in fact, based on the latest report, whether it's from Wallace or other sources, basically they're showing a double-digit CAGR growth. And right now, China, Japan, South Korea basically are the dominating leading members. But of course, with the efforts that Taiwan and of course Singapore and other countries are now putting in, I believe that there'll be 6 or 7 major players in the next decade or so. Okay, so in terms of the market segment verticals, in terms of applications for 3D printing, so I would say the 4 main applications that are coming up so far, based on numbers, based on statistics, which I'll share in a while, primarily in the aerospace sector, automotives, medical, dental, and consumer. And actually the services basically are set to be the fastest growing, okay? CAGR about 34.5%. So services includes design services, prototyping, and short-run manufacturing services. Currently, in terms of, if you look at the global supply chain, there are top 3 leaders, Stratasys, 3D Systems. Basically, they hold 61% of the market share. There are several small players and a lot of emerging market players as well coming through. Those actually have presented, they'll present great innovation opportunities in time to come. If you look at from a country level, I didn't have Taiwan here because when I prepared this, I obviously didn't know much what was going on here, but I would say now Taiwan would be up here. So China, Japan, South Korea, they all have huge incentives, huge government support behind them. And I added Singapore. Singapore actually, in the last 10 years, the government actually has poured in several hundreds of millions of dollars into research. So we have set up no less than 6 dedicated and additive manufacturing centers in the universities, polytechnics, and industrial research institutes like SIMTech and ARTC. In recent years, as you probably may have also read, Singapore has been traditionally a very MNC led type of economy. So we have a lot of foreign direct investments. But again, in recent years, because of the fact that a lot of countries now offer similar types of incentives, and from a cost structure perspective, Singapore is no longer competitive. So there's a lot of focus now to focus on our SMEs and our startups, so that we can create more Singapore Inc. Global companies. This is some numbers just to share quickly. So you can see industrial, aerospace, defense. I think all these numbers add up. By 2020, you're looking at something like, from a service perspective, it's about $8 billion in revenue. And I think a lot of different applications, in the industrial space right now is gaining momentum. Aerospace leading the way. Automotives in recent months, there were several news reports, especially from the German big car makers, Daimler, BMW, and so on and so forth. So they are all in this space. Even Volvo, which is now owned by Geely in China, they are also using mainly for the jigs and fixtures for making cars and prototyping. So you can see for yourself that this is no longer a hype. Obviously, the revenues are still tiny compared to what the opportunity is, but definitely is growing rapidly. skip this. So from a global value chain perspective, as mentioned, the three largest players right now, Stratasys, 3D System, and I forgot the last one was with US. So they occupy 61% of APAC market share. And you can see that from the material makers to the formulators, to the solution providers and service bureaus and so on and so forth. This is the current view of what it is today. So in the future, we believe that Asia-Pac, and a lot of these companies actually have Asia-Pacific offices for that reason. They're investing aggressively. Even in Singapore, we are like a 5.5 million island state. I think most of the major players, from the Germans, from the Swedish companies, they all have set up competency centers in additive manufacturing. So obviously, there's a lot of room for growth in this. And again, from a demand vertical analysis, you can see some of the numbers from APAC versus the global market. So still relatively small, but obviously we expect it to grow. And some of the demand drivers, obviously, you can see whether it's in aerospace, biomedical, automotives, and even oil and gas, okay, which is of course a tiny fraction. We believe the reason for a lot of demand drivers is mainly on the potential for on-site production, on-demand materialization of complex durable parts in remote locations where it's not easy to transport, to produce these parts. And of course, the mass customization in this space, for example, like with healthcare, offers the potential to improve your patient-specific outcomes. Okay, I will just, I've been given some, so with that sort of perspective, so it's a very, I would say from my personal view, this is a very exciting space. And I think the Singapore government has sort of recognized, this several years ago. And these are just some of the, news reports that I just took from the websites that is published. So, you can see, there's a lot of focus primarily is also to create more high-value jobs. In Singapore, you may not know this, but a lot of PMETs are the professional engineers and technicians level, the managers. There's a sort of a structural mismatch right now where jobs are present, but the skill sets are not there. So you end up having attrition and forced attrition, retrenchment, and the people who actually are retrenched can't find the jobs. So there is a huge effort right now going on in Singapore to look at the workforce transformation in terms of reskilling all these PMETs. And additive manufacturing is part of that. It's not the only one. In fact, probably a little known fact to all of you is the fact that manufacturing itself occupies about 20% of our GDP in Singapore. And it's a very important contribution for our GDP because it enables a lot of the horizontal industries as well, such as the services and financials. So because of that, as I mentioned, we have been investing. But some of the challenges, and I just briefly run this through, is from our perspective, we see is, of course, in most cases, it's still considered emerging technology. And if you try to set up a new additive manufacturing facility, these are the kind of bureaucracy and the process that you go through. You have different agency approvals and things like that. You have a laser license to operate some of those more complex powder bed machines and so on and so forth. The other thing is that we recognize that for us to play in this space, especially for Singapore, you need to be not just manufacturing part, just because of our cost structure. You need to be able to create the technology and the value creation. A very good example would be a country like Israel. So you are able to invest in intellectual property and able to commercialize these intellectual property. So to date, of course, if you look at the chart, obviously Singapore is nowhere there, right? US by far is still the largest innovators in the world, followed by Japan and China. The third thing is that, of course, a lot of the industry players would agree with me on this, is that there's still generally a lack of markets. As much as, yes, there's some niche pockets of applications which you can monetize immediately, and it's not easily replicated. So there's no unique business model today that you could describe that would be able to, you can just sort of plug and play in all the business. So what we have found in our discussions with industry members, with the public service policy makers, is that we need to approach it in a very customized fashion. So part of the job that I do personally and my team, my small team, which is basically a national program office set up, is to focus on how do we engage the private sector and help them to customize the technology for their application and for their business. So this is the whole mission of, so I'll just leave you with this one. Just quickly on the dynamic, about 5 minutes left, so I'm just going to run through this very fast. So we're basically funded out for National Research Foundation. Is something similar to what NSF is in the US. Basically focused on expanding our ecosystem. We're very focused on not just our local, but we're also very keen to partner with international players. We want to set up a platform for cascading, for implementation, and of course to catalyze new business growth and new business models. And I mentioned earlier about the lack of standards and certification. This is a space that we are now actively exploring. We've actually visited the ASTM office. We've talked to them. We've established some formal relationship and partnership with them as well. In terms of organization, we are, like I said, we are a program office, so we leverage on the existing public sector funded university AM centers. The three big STEM universities, or three only ones in Singapore are NUS, National University of Singapore, and Nanyang Technology University, and Singapore Technology University of Design. Each of these hubs, we basically have dedicated staff to execute projects. We provide some flow-through funding to augment the infrastructure. Basically, we influence the decision-making process for some of these machine acquisition, more focused on industrial capable machines rather than research tools. We also partner with the research institutes from A-STAR. A-STAR is one of our largest research agency in Singapore. And we also work with our polytechnics, which is also, it's a very key tertiary institution that basically generate a lot of technicians and engineers and so on and so forth. So we have been working with companies. I think we've been around for about 2 years now, coming to operation. And we work with startups, we work with local SMEs, we work with global partners. And I think from our current initial assessment, we think there's huge potential. So a lot of companies we talk to are very keen to establish, what's the way to move forward as far as their business concerned with additive manufacturing. And the way we do this is we try to seed and enhance the company capabilities. We actually fund them. We do a co-funding to de-risk some of the entry points for them in terms through projects. So if a company, let's say, require a very customized large format 3D printer, which is not existing in the market today, we will matchmake that with a university or research institute, and then we will co-fund the project to make it happen. And we're very market driven, so and also time focused. So we don't do projects for 5 years. Most of the projects are 6 months to 1 year. We need the time to market speed as well. In terms of IP, I mentioned earlier that Singapore is obviously not there on the world map in terms of IP. So what we have done is actually we have tapped on our global network. So IPI is an intellectual property intermediary. It's an agency that was set up. Basically, they have set up these different partnerships with different networks in Europe, in the US, in Australia, in Germany, and so on and so forth. So we tapped on their tech partnership network like CSRO, Fronova, GST, TNO, and so on and so forth. So we can actually potentially go through them to basically look at what are some of the more interesting IPs that we can leverage, and then we can then apply for our own company application. One example just to share with you, this is one company in Singapore, is in the marine offshore. They basically wanted to create a service bureau dedicated to the marine offshore and oil and gas sector. So Singapore has, despite its size, we have one of the largest petrochemical refinery facilities, right? So in fact, we actually have a separate island out of Singapore Island to host those. So Shell, Mobil, Exxon Mobil, and so forth, they're all there. And this company actually, worked with us. So we had to we looked at the current technology offering out there. and then we basically decided that we would work with them to develop customized systems that will cater to what they need to service their customers. So some of the pain points that I would say in the current state-of-the-art technology that's existing today is large pots are still highly costly to build. It doesn't make sense actually most of the time to build large pots with 3D printing. But however, there are some business case for those kind of things. So for example, if you have a ship that dock, and typically if they have parts that need to be replaced, they would have to wait for 6 months, right, for the custard part from South Korea. And that itself is a problem. So what we're thinking now is with additive manufacturing, with on-demand production, we could potentially build these parts on-site at the Singapore docks within 2 weeks. And then you certify it by a class company like DNV, GL, or Lloyd's registers, and then you install it, and then off you go. So that this will transform and disrupt the entire current supply chain for the marine offshore sector. I mentioned we have funding programs, so I'm going to skip this. We have global partnerships, so some of you may be familiar, some of you, these are all announced in the news. So we have tie-up with Invention Science Fund, LLC. This is a Seattle-based private equity company. They have a network of IPs around the world. And what we looked at is one of the not so talked about areas in the cybersecurity, which is when you go into the think about digital supply chain, how do you securitize the transfer of digital files, which are essentially IPs of the companies. And at the same time, you need to be able to have solutions for the machines, right, that is on some of these satellite distributed manufacturing sites to decide whether they can print, how many times they can print, and so on and so forth. So these are the type of things that we are exploring. And we are actually developing some basically solutions around this with them. There's a startup, Gilmore Space Technology. This is a startup, is an Australian guy, but he's based in Singapore. So we're actually looking at also application in this emerging space of space industry. To date, of course, this looks like another science fiction, but I would say within our lifetimes, all our lifetimes here, I think next 30 years, the space industry will take off. So we are developing basically hybrid fuels using 3D printing. So we help them to develop a customized system to enable that. And most recently, they got the first Series A funding from Australian investors. There's another local startup, basically is on the water membrane technology. So Singapore, being a small island state, we don't have natural resources. Most of our water comes from Malaysia, and we always have this risk of being shut down because of some disputes here and there. So there's a lot of focus on finding alternative sources of clean water. Singapore is the world leader in technology as far as water membrane is concerned. And we're actually very happy that we could establish a partnership with this local company. This company actually so far has obtained about 14 million Series B funding, and they're expanding rapidly in emerging markets like China and Indonesia. So all in all, I guess my time is up, so I just wrap up with this. So we have about, currently in the 2 years, we have established about 70 million in major industry verticals in terms of funding on projects. This works out to about 70 projects, and this is a co-funded model, so half of it comes from us, half of it comes from the industry. Some of it comes from the universities through the professional expertise and in-kinds and so on and so forth. So you can see that we are actually covering every vertical that we believe will be important and has the traction for additive manufacturing adoption in the future. I probably want to just share one final thing is on the startup ecosystem. So this is something very close to me, close to my heart personally, and it was actually interesting when we first started this program office. We found that a lot of startups approaches, I guess primarily attracted by the fact that we offer funding. So, but they soon found out that we are not VCs. So, but we could still help them through supporting some of the projects to help them develop the technology, fine-tune, and even to some extent market access as well. So we work with not just local companies. Some of these companies you probably might recognize as 3 Italian companies. There's 2 Australian, and then 3 Australian, and the rest are all Singapore companies. And some of these, like just highlight here, the Osteoport International. This is a very interesting company. It's been actually not a startup. It's been around for 10 years. What they do is they actually manufacture these bioscaffolds, And these products actually have been approved by FDA and CE in Europe. So they are now basically expanding rapidly in terms of market distribution on their solutions. And another story is on Structo. Structo is actually, if you guys probably may have heard of carbon 3D, but perhaps not Structo. But in terms of the technology, it's a vat polymerization based technology. Basically they have established this focus on the dental market. So in the last short span of one plus years, they have actually sold something like 40, 50 machines. So very, very up and coming in terms of potential. All right, with that, thanks very much for your attention. If you have questions later, I'll be happy to talk to you separately. Thank you very much.
Thank you, Dr. Ho. Of course, the time is running out, so if you have a question, please contact Dr. Ho individually. And let's move on to next speaker. The next speaker is Kai Fuhrer from the regional manager, SHT South German Aerospace Center, DLR, Germany. And okay, his presentation title is Performance Increase for Additive Manufactured Part by Topology Optimization, How to Use the lattice structure to set weight and increase functionality. Let's welcome Dr. Zay. Dr. Kai.